Hi, I'm Lydia and I'm solving video solution number 5. So this problem asks us to look at two groups of students, one that started a test with easy questions and one that started with hard questions. So here are the statistics from that. So to find the null hypothesis, that is going to be x1 minus x2 equals 0, showing that there's no difference depending on which hardness of questions they start on. And the alternate hypothesis is x1 minus x2 does not equal 0, meaning that there is some kind of difference. So part A asks us to use the appropriate statistical test at a 5% significance level to determine if students perform better on average when the test begins with easy questions. So to start out, we need to find the test statistic, so that will be this formula: the average of x1 minus the average of x2 divided by the square root of the standard deviation squared divided by n plus the standard deviation squared divided by n. So for this problem, it will be 82 minus 76 over the square root of 14 squared divided by 25 plus 9 squared divided by 25, which equals 1.8025. So that's our t value that we'll be looking up on the table, and the df to find the row that we're looking under is going to be, for this problem, n1 plus n2 minus 2. So our sample size of the first group is 25 plus the sample size of the second group, 25 minus 2 will equal 48. So in the t table, the closest row to 48 is going to be 40. And so when we look in row 40 at the t value of 1.80, we find that the p value will be between 0.025 and 0.05, but since this is a two-tailed test, we'll multiply both of those by 2, which means that the p value will be between 0.05 and 0.1. And so since this is bigger than our significance level of 5%, we are going to fail to reject the null because it's bigger than the 5% significance or statistical test, and we're failing to reject it because we do not have significant evidence that there is a difference in the population mean of scores of students who started with easy or hard questions. So then the second part of this problem shows a histogram for the easy questions first group and asks if it affects the validity of the test performed in part A. So this graph is skewed left, which makes this whole test not valid, because to be valid, the distribution from where the data came from must be normal, and since this is not normal, it's skewed left. That makes the entire test not valid.